This is the first leak of the server platform Neoverse N2, codenamed Zeus. This picture, guys, this is the first leak, and we can see here a lot of informations. At first, we do see that there is a 72 cores, and most probably 4 megabyte L3 cache, which results into 288 megabyte L3 cache. If we compare to the AMD Zen 3 Milan platform, the server platform, yeah, there is more cores and more L3 cache. Even the 4 megabytes per core, it stays the same. But we also can see here it's using TSMC 7 nanometer, but there is a 4 HBM2 channels and also DDR5, guys. So AMD is planning for this year and the next year for the Zen 3 DDR4, and ARM Zeus will have a DDR5 support. So it's kind of big thing. And not speaking about the HBM, because this is the key factor for the performance of the Fujitsu supercomputer, the Fukagu. So it doesn't look really good for the Zen 3 platform. Let's take a look on the history of the server platform of this ARM. The first platform was the Cosmos, which was really not good. It was probably based on the Cortex A72, which is like a half IPC of the Intel and AMD. This is really not good. But the Neoverse N1 was based on the Cortex A76. This was the first desktop class core, and it has an IPC just below like a 90% of the Intel Comet Lake. This is not bad, and it's really close to the Zen 2, and it caused a lot of problems. It was actually for example, the Amazon Graviton 2 literally destroyed Zen 1 server platform from AMD and put a lot of problems for Zen 2 ROM platform. So until today, we didn't know what is the Zeus platform. And because this is scheduled 1 year, 2020, after Neoverse N1, everybody was supposing, because this is based on the Cortex A76, so everybody would suggest that this is based on the Cortex 77, guys. And but the thing is, this was released on February 2019, and this will be released end of 2020. So there is almost kind of 1.5 year range between those. So I don't think so. It will be based on Cortex A77. So let's go back to take a look on the die sizes and try to estimate what the core is used here. If we look at the die size of the cores, we can compare on the 7 nanometer TSMC, which is providing, ARM is providing the numbers. We can see there is a Cortex A76, the Neoverse has a 1.4 square millimeters. And we can see also because it's 50-50 with the 4 megabytes L3 cache, and 4 megabytes L3 cache has about 2 square millimeters. So the core itself has also 2 square millimeters. So we need to match the available cores. So the first suggestion was the Cortex 77. This is 1 year after 76, so there was a logical match. But it has only 1.4 square millimeter, including half megabyte L2 cache, and I think there is a half megabyte L2 cache, so it's still smaller. So it's too small to be part of the Zeus platform, actually. Cortex A78 even has a higher IPC. It has a like 5% less transistors, so it's even smaller. So it's also no way. And The only core which is available is Cortex X1 actually, and the numbers it suggests it's about 2.2 square millimeters, including 1 megabyte L2 cache. But because we have a half megabyte cache here, and we subtract those half megabyte cache, we have exactly 2 square millimeters, and it's exactly match this picture. Well, and this is the biggest nightmare which can happen to AMD and Intel, because you can see it's providing X1 is providing 30% higher IPC than the Zen 2, while being almost twice smaller, and there is also SVE vector. So let's take a look on the architecture. So this is the architecture, and we can see here Cortex 77 here, and this year evolution Cortex 78 and X1, and X1 is a beast. You can see 4 LAUs here and 2 branches, so it's like 6 wide. It's much wider than the Intel and AMD. It has 5 memory units, guys. This is the kind of the widest CPU in terms of memory units. This and the first CPU on the world I can see it can do 3 load instructions per cycle. This is the first CPU on the world, so it's even bigger than Apple cores. So it's really not a small efficient cores anymore, because it can do 15 micro ops per cycle. This is really beast. This is super wide beast, and a lot of people underestimate those small cores. It's not the small cores. They are underestimate the ARM cores, but this Cortex X1 is really big beast. And the modification I suggest is I think they will probably, because this Zeus is using SVE vectors, which are supporting 248-bit wide vectors, but I think they will use 256-bit wide vectors, and they will keep the 4 pipelines. I don't think so they will go and reduce once they have all the scheduler is ready. But I think they will use kind of sparse architecture. They will use only the same kind of AMD is using and Apple is using. So they will be less functionality per each pipeline. They will use one multiplication here. Second, we'll have addition and multiplication and addition. So it will behave like a 2 full floating point units, but it will be split into 4 pipelines, so increasing theoretically the IPC. If the mixture of the instructions is pretty nice, they can increase the IPC. So I think this is the modification we can expect from the Cortex X1 for the Zeus platform using SVE. And let's take a look on the IPC, and look at here this graph. This is Zen 2 is somewhere here. Zen 2 is matching Cortex A77, and even is little stronger. In the integer, Cortex A77 is like 7% stronger. So this X1 is like more than 30% faster than Zen 2. So it will be much faster also than Zen 3, because if Zen 3 will have somewhere between 15 and 20% IPC uplift, it will be still not enough. Zen 3 is somewhere here, guys. And so this Cortex X1 will have a higher IPC than AMD Zen 3 platform. This is a big problem, and even bigger for Intel, because Intel with the Comet Lake is somewhere here. It's really big problem for both Intel and AMD. But AMD was kind of pushing a lot, but it looks like they are not pushing enough. So this is the IPC graph of the cores today and in some history, and you can see the the first server platform of ARM was really slow in terms of IPC. It has a really like a half IPC, less than half IPC of the Intel and AMD. Was really not good in terms of performance. But Neoverse N1 has an IPC somewhere here. You can see this Cortex A76. It literally matched Zen 1 performance, the IPC, and it was below Intel Comet Lake and Skylake, and quite close to Zen 2, even because it was really somewhere here in time. So that's why the Graviton 2 makes us so much problem to AMD Zen 2, and was destroying actually the Zen 1 pretty easily. But now we are talking about Cortex X1, which is here. It has a much higher IPC than Intel Ice Lake, much higher IPC than Zen 2. And it's really bad situation. And yeah, Apple is like 2 levels above everybody else, but Apple is not providing the server CPUs, so we don't need to care about it. But the Cortex X1 looks really super powerful. But this is not everything. There is even coming something bigger than this. And you can see this is kind of prediction of the Nuvia performance. They release some information, so Nuvia performance will be super strong, and it will be available also probably in the servers. And there is coming next year the Cortex X1, the Matterhorn, brand new architecture with the IPC somewhere on the level of a Apple A12 Vortex core. This is, you can see this will absolutely destroy Golden Cove. Golden Cove with a 40% IPC uplift here. Golden Cove will be destroyed by the ARM Matterhorn. This is not. This is really pretty serious situation, and even Zen 4, even Zen 4 will be here or maybe here in 2022. Zen 4 will have big problems. AMD and Intel will have problems with new Matterhorn architecture. So even bigger problems is coming for the x86. So the Zeus platform is just the beginning of the trouble, and it's a beginning of the expansion of ARM in the servers. And you know, the Matterhorn, the architecture should be available in the silicon next year, end of the next year. But it means they are going to tape out soon. Like the architecture right now is already finished. So the customers, they probably know internal informations about the IPC. So I'm really worried about AMD right now, because I am AMD fan, but it looks like the future is really ARM heavy in terms of servers, and I think ARM might gain majority in the servers in maybe 3 years only. So this is really serious situation. So I hope you like this video, and yeah, more exciting stuff is coming soon. Next year will be super interesting in terms of CPU architecture.